All right, this next lesson is called Area of Regular Polygons, Circles, and Irregular Figures. Right. One definition to start. Recall that a regular polygon is a polygon with all angles equal and all sides equal. Regular polygon. Okay, so now this next little blurb. You can circumscribe a circle about any regular polygon. The center of a regular polygon is the center of the circumscribed circle. The radius, which we've talked about already a lot, is the distance from the center to the vertex. And the apothem, that's new. The apothem is the perpendicular distance from the center to a side. So here we have a regular pentagon. We have a circle that's going through all the vertices, so the circle is circumscribed about the polygon. This is the center. That's the radius. In this segment right here, that is called the apothem. Okay, so again, the apothem is a segment from the center to the polygon, and it's perpendicular to the side. Okay, so this is the apothem right here. That's new. And here's the formula that you're going to need for the area of any regular polygon. Okay, if a polygon has an area of capital A, a perimeter of P, and an apothem of little a, then the area equals 1/2 times the perimeter times the apothem. Okay, so that's the formula. That's the formula for the area of any regular polygon. Area equals 1/2 times perimeter times apothem. Okay, so here we go. Example 1. This is just an intro problem right here. The figure below is a regular pentagon with radii and an apothem drawn. Okay, so just to help you see it better, let's color the apothem in blue. This is the apothem right there in blue. Okay, that's the apothem. Okay, because it goes from the center to a side and it's perpendicular to that side. So that blue segment, that's the apothem. Find the measure of each numbered angle. So it's a pentagon, so that means there's 5 sides. So it means there's 5 central angles, okay? 5 central angles. 1, 2, 3, 4. And this 5th one is cut in half by the apothem, okay? But there's 5 central angles. So measure of angle 1 is a central angle. So I'm going to say that the measure of angle 1 equals 360 divided by 5 because there's 5 central angles. So the measure of angle 1 equals 72 degrees. Now, the apothem bisects the central angle. So that means that the measure of angle 2 is going to equal 1/2 of 72. Okay, again, notice how angle 2 is not a central angle. Angle 1 is. Central angle there, 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 and this last one is cut in half by the apothem. Okay, so the measure of angle 2 is going to equal 1/2 of 72. I'm just going to jot down the apothem bisects the central angle so you know why I did that. The apothem bisects the central angle. So the measure of angle 2 equals 36 degrees. Now to find the last angle, angle 3, you have a triangle. Okay, notice how we have this triangle. You have the 90-degree angle, and we just found out that the measure of angle 2 was 36. So I'm going to say that the measure of angle 3 plus 90 plus 36 has to equal 180, okay? Triangle angle sum theorem. So the measure of angle 3 plus 126 has to equal 180. 180 minus 126 equals 54 degrees. Okay. Okay. So the next three examples, examples 2, 3, and 4, all come from this formula at the bottom of the first page. The area of a regular polygon equals 1/2 times the perimeter times the apothem. Now, in the past, I have usually used a lowercase p for perimeter. This right here has a capital P, so I may or may not use a capital P going forward. I'm used to using a lowercase p, so just keep in mind I may use a lowercase p, whereas this says a capital P right there. And usually what I do when I do these is I write the apothem first. I'm used to doing 1/2 times apothem times perimeter. This formula says perimeter first. Just remember, it does not matter which way you multiply, right? 3 times 7 equals 7 times 3. So like I said, the next three examples come from that formula. We have one easy one and then 2 hard ones, okay? Now this one is an easy one. Find the area of a regular decagon, okay, that means 10 sides. You can count if you want, but a decagon means 10 sides. With a 12.3-inch apothem and 8-inch sides, okay? So first let's find the perimeter, okay? Ten sides, 8 inches for each side. The perimeter equals 80. Now let's go into the formula. Area equals 1/2 times the apothem times the perimeter. The apothem is labeled. Again, this is why this was an easy one. It was labeled for you. The apothem is 12.3. Area equals 1/2 times 12.3 times the perimeter of 80. Okay. It's going to give you 492 inches squared. That one was nice and easy because you were given the actual length of the apothem, and all you had to do to get the perimeter is do 8 times 10 for 10 sides. So that one was pretty easy. The next one will not. The next two will not be easy though. Okay. Find the area of the regular hexagon below as a radical in simplest form and as a decimal rounded to nearest tenth. So it wants the answer 2 ways. Okay. Now, so we're going to use the same formula, 1/2 times the apothem times the perimeter. Now the perimeter is easy. The perimeter is just 60, right? 10 times 6. Ten times 6 is 60. I'll do that math down here. Perimeter equals 10 times 6. Perimeter equals 60. That's the easy part. The hard part is finding the apothem. What is the apothem? It's not labeled. Okay, so here's what I'm going to do. Let's label all the central angles. Okay, there's 6 central angles because it's a hexagon. 6. So 360 divided by 6 for 6 sides gives you 60 degrees for each central angle. Okay, 60 for each central angle. 60, 60, 60, 60, 60. And the last central angle is bisected by the apothem. So each of these angles are going to be 30. that's 30, then this angle down here is going to be 60. So we have a 30, 60, 90 triangle. Let's work off of that. Draw it over here. $30, 60, 90 triangle. 30, 60, 90. Okay. Now, I'm trying to solve for the apothem. Okay, so I'll label that. The question is, what is the side? If you look at these two triangles down here, these are actually going to be congruent because of hypotenuse leg. Okay. This leg is the same, so reflexive property, and the hypotenuses are congruent. So hypotenuse leg. So bottom line, why I'm doing that is because that means that each of these are going to be the same. So each of these sides, each of these segments are going to be 5. So this is 5 down here. Half of 10. That's why it's 5. Okay. So we have a 30, 60, 90 triangle. And the formula is long leg equals short leg times square root of 3. The long leg represents the apothem. So the apothem equals the short leg 5 times the square root of 3. Okay? Okay, so now we got the apothem. Now let's get the area. Okay, area equals 1/2 times the apothem times the perimeter. The apothem we just solved for is 5 square root of 3. The perimeter, so that was the apothem right there. The perimeter we got a while ago is 60. Okay, so the question wants the answer in simplest radical form, and it wants a decimal. So in simplest radical form, it would be 150 square root of 3. And multiply everything with the square root. That's centimeters squared. And as a decimal, multiply those out, and you get 259.8. Centimeters squared. Okay. Example 4. Find the area of the regular pentagon below as a decimal rounded to its nearest tenth. Okay. Now, keep in mind, we're going to use the same formula, 1/2 times the apothem times the perimeter, because it's a regular pentagon. Now, I'm going to draw in all the central angles because they're not drawn in. Okay, let me draw in all the central angles. And by the way, that segment is not the apothem because it's not perpendicular to a side. Okay, so that's not the apothem, by the way. But let me draw in all the central angles first. There we go. Now I'm also going to draw in the apothem. So let me do that in blue so you can see it better. It's not perfect, but that's the apothem in blue. Okay. Right angle right there. Okay. Now what I'm going to do is let's find all the central angles. Okay, it's a pentagon, so there's 5 central angles. So you're going to do 360 divided by 5. Each central angle is 72 degrees. You may have that memorized by now, but you just do 360 divided by 5. Each central angle is 72. 72, 72, 72, 72. And remember, the apothem bisects the other central angle, so 36 and 36. Now, let's just get this angle down here while we're at it. 54 degrees. Now, you may be thinking, can you use the special right triangles, 30, 60, 90, or 45, 45, 90? No, because look at the angle measures. It's not 30, 60, 90, and it's not 45, 45, 90. So how do you solve for the sides? How do you solve for the apothem? And by the way, you also have to find the perimeter. Don't forget about that. You can use trigonometry, sine, cosine, and tangent. So let me take this triangle right here and let me draw it off to the side, up here. 90, 54, 36. This is 4. And let's use some letters here. Let's call this, let's do x over here. Let's do y for this. We have to solve for x and y, okay? Y is, I used y for the apothem. I could use a if I wanted. I just want y. And I used x for the bottom side, which we're going to use to get the perimeter, okay? Let's solve for x first. You're going to use sine, okay? Sine of 36 equals opposite x over hypotenuse 4. Solve for x, you're going to do 4 times sine of 36. Now, what I'm going to say is write out as many decimals as possible. Write out all of them for now. We'll round at the end, okay? 2.35114 1009. Let's round at the end, the very end. Now let's solve for y. So again, I'll work off a 36-degree angle. I'll do cosine of 36. Equals adjacent y over hypotenuse 4. So y is going to equal 4 times cosine 36, which is going to be approximately, because we are rounding still, kind of. It's not exact. 3.23606 7977. Now, again, that was y, so that was the apothem. So I'll just label that. This is the apothem. Now let's get the perimeter. You may be tempted to do 5 times that to get the perimeter. That is not correct because that was just half of the side. So you're going to do 10 times that number. It's going to be about 23. .5114 1009. Okay, so now we have the perimeter, we have the apothem, great. Now let's get the area. Okay, so area equals 1/2 times the apothem times the perimeter. So area equals 1/2 times the apothem. We established that earlier, 3.23606. Write out all the decimals for now. We'll round at the very end. .7977. That's the apothem. And then times the perimeter, 23.5114. .1009. Now we'll multiply those 3 numbers out and we'll see what we get for the area. Now we'll round to the nearest tenth like the problem said. Okay? So let's multiply those numbers out. should come to about 38.0. After 38.0422, so I'll say 38.0, I'll put units squared. Okay. You may remember the area of a circle formula is area equals pi times radius squared. Okay, so let's do a working backwards problem. Let's do a problem where I give you the area of a circle and I ask you what is the approximate length of the radius. So let's just copy down the formula first. Area equals pi times radius squared. I gave you the area for this problem, 153.94. Pi times radius squared. What you're going to do now is you're going to divide by pi. I'll give you 49.00062388. If you want to solve for the radius, you can take the square root of that. And we only want the positive square root because it's a distance. So that's going to give you 7.0000 a million zeros, 44563. So I'm just going to say R is approximately 9. I mean 7. R is approximately 7 inches. Find the area of sector JKL. So this is a sector. This shaded region, that's called a sector, part of a circle. Okay, it's a sector. Okay, so remember when we did an arc length? You took the circumference of the entire circle and you did times just the portion you wanted over 360. That's going to be what we're going to do here. We're going to find the area of the entire circle, and then we're going to multiply that by just the part we want. Okay, so area is going to equal pi times radius squared times the measure of the arc over 360. That's what we're basically going to do. Okay, because pi times radius squared, that's the entire circle's area, see above, and then times just the portion we want over 360. Okay? Pi times radius of 16 squared. That would give you the entire circle, but we just want this sector, so I'm going to do times 36 over 360. The question said give your answer in terms of pi. That means multiply everything but the pi. Okay, so you're going to do 16 squared, that's 256, times 36, divided by 360. I messed up. 16 times 16 times 36, divided by 360, 25.6 pi. Inches squared. Okay? Give your answer in terms of pi, so there's the pi. That's how you do the area of a sector. If I take it one step further, okay, and I say, what is the area of the shaded segment? So this is called the shaded segment for a circle. What's the area of that shaded segment? How could you find that? What you're going to do is you're going to get the area of the entire sector, like we just did, and then you're going to subtract out the area of the triangle. Okay? So I'm going to say, we're going to do the area of sector GHJ minus the area of triangle GHJ. Okay, so that's how we're going to do it. This is 90, so this is also 90. The arc is the same as the central angle. Okay, so let's start by doing the area of the sector. Pi times the radius, 14, squared, times the measure of the arc, which is 90 over 360. Okay, that's like we just did in example 6. So that's the area of sector GHJ. But I'm also going to subtract out the area of triangle GHJ. Okay, all the radii are congruent. So if this is 14, this is also 14. So 1/2 times base times height. Okay, 14 squared is 196 times 90 divided by 360. 49 pi. 14 times 14 divided by 2 would be 98. Okay, so just to recap, I did 14 squared is 196 times 90 divided by 360. Gives me 49. I haven't done anything with the pi yet. So 49 pi minus 98 when you do this. Okay, so now I'll do 49 times pi. And then I'll subtract 98. (49 times pi is 153.93. Minus 98. Then I'll round, I'll say approximately 55.9 meters squared. Okay. Okay, this last definition is called an irregular figure. An irregular figure is a figure that cannot be classified into the specific shapes we have studied. To find areas of irregular figures, separate the figure into shapes of which we can find the area. Draw auxiliary lines as necessary, meaning feel free to draw any lines you want to help you see different shapes. That's an auxiliary line. Okay, so here we go. Find the area of this figure below. Okay, so here's what I'm going to do. Okay, first I'm going to pretend that this is filled in. Okay, I'm going to pretend that this is part of the shape. I'm going to get the area of the rectangle. Then I'll get the area of the semicircle. Okay, and then I'm going to subtract out the area of the triangle. Okay, we're going to get the area of the rectangle, then we'll get the area of the semicircle, and then we'll subtract out the area of the triangle. Okay, so let's start with the rectangle. Okay, the rectangle is going to be 19 times 6, right? (19 times 6 equals 114). Okay, 19 times 6 for the rectangle. Now remember, I have to subtract out the triangle at the end. Now let's do the semicircle. Half a circle, not an entire circle. Semicircle. You know the area of a circle is pi times radius squared. So the area of a semicircle is 1/2 pi times radius squared. So 1/2 pi. The radius is 3, because this entire segment is 6. So the radius is 3. So 1/2 pi times the radius 3 squared. For now, I'm just going to leave that as 4.5 pi. At the end, we'll get a decimal. I'm just going to leave it as 4.5 pi for now. Now, the triangle is a little bit of an issue, okay? So we got the area of the rectangle, we got the area of the semicircle, but we have to subtract out the area of the triangle, which is not going to be that easy to find. So I'm going to do that over here. And I'm going to draw a diagram. It is going to be an equilateral triangle because this side is 6. I don't know if you can see. This is 6. This is 6. That's what those are pointing to, okay? And this side is 6, okay? So each side of the triangle is 6. Let me make, I need to draw a bigger diagram. Hold on one second. Okay, that's better, nice and big, okay? So like I said, each side of the triangle is the same. That means it's an equilateral triangle, okay? So 60, 60. Now this blue segment, that's going to be the height. Okay, 1/2 base times height. So it means that these are each going to be 30 degrees up here. We just established that each side is 6. And these are going to be 3 and 3. So the question is, what is the height of that triangle? What is the blue segment? That's the long leg. Long leg equals short leg times square root of 3. So 3 square root of 3. So now we can finally get the area of the triangle. The triangle is going to be 1/2 base times height. The base is any side, so I'll say the base is 6, and the height, which is the long leg above, is 3 square root of 3. So bottom line, the area of that triangle, which we have to subtract at the end, will be 9 square root of 3. Now we can finally get our answer, okay? The total area of this ugly looking shape equals 114 for the rectangle plus 4.5 pi for the semicircle minus 9 square root of 3 for the triangle, which we had to subtract out. You can do that in your calculator, and you're going to get 112.5. Units squared. That lesson was kind of long, okay? But hopefully you were able to follow it. A lot of it was hard though, okay? Area of regular polygons, circles, and irregular figures.